If y equals natural log of x, then y prime is, the derivative of natural log of x is 1 over x. This is what I want to prove in this video, okay? Using what we just talked about in the previous section. Y is the derivative of natural log of x, 1 over x, okay? So take a look. Let's just say that we have a function f of x that is natural log of x. Before we take the derivative of this, what I want you to do is rewrite this. Rewrite in exponential form. Why? Because in the previous section, we just learned how to take the derivative of e to the x. So what is this in exponential form? What's the base of this log expression? Natural log means the base is e. The exponent is what's on the other side of the equal sign, right? So look, the exponent is f of x, and this equals what? X, okay? Now, what I'm going to do is I'm going to take the derivative of both sides, okay? So take the derivative of e raised to the f of x and take the derivative of x. So I'm doing the same thing to both sides. I'm taking the derivative of both sides. So I'll put this one in here, and I'll put this one in here, okay? So the right side is easy, right? What is the derivative of x with respect to x? Well, that's just 1, okay? Now the left side though, this is what we talked about in section 2.2. Derivative of e to the f of x is e to the f of x times the derivative of that exponent function, so f prime of x. So that's the chain rule, right? Now, let me take a look at this. Where am I? All right, look at this for me, okay? What's this orange chunk? What is that orange thing? Isn't that what x is, right? See, e to the f of x is x. I'm going to make a substitution here, okay? Instead of e to the f of x, I'll say that's x times f prime of x equals, what number on the right side? Just 1. Keep it the same. Now, what am I going to do to both sides to have f prime by itself? Well, divide both sides by x. So that's why, see, this x cancels out over here, and we're left with f prime of x equals 1 over x. So that's how we can prove this rule that we will be using. So know this, okay? So if you ever see natural log of x, and I ask you to take the derivative of this expression, what's that equal to? 1 over x. Okay, so let's use this in these 2 examples on the bottom of page 87. So differentiate. Y equals 3 times natural log of x. The answer is 3 over x, but let's see why. Okay, so if you take the derivative of this, okay, y prime is equal to, you can pull out the 3 to the front, but just take the derivative of natural log of x. Okay, so the 3 just waiting, but we just said that this is equal to what? That is equal to 1 over x, right? So what is 3 times 1 over x? 3 over x. Okay, so that's got to be the answer right here, okay? So you can do similar problems, but you can come up with the rule here. Like, let's say if you have y equals 7 natural log of x, the derivative is got to be 7 over x, okay? If you have, let me just do one more and then I'll move on, okay? If you have y equals negative 5 natural log of x, what's got to be the derivative of that? Negative 5 over x, okay? So if you just have a constant, a coefficient, multiplying to the natural log expression, you can just do it like that, okay? Now, this one looks a little bit different, so let's do this one, okay? So here, when you take the derivative of natural log of 3x, we have to do 1 over 3x. But here we have to multiply this by the derivative of the inside function, which is 3x. It's a little interesting, right? Now, I kind of wanted to save this for the next page, but if the log argument is more than just x, you have to find the derivative of that 3x, that log argument, and multiply by your work. Okay, so that's going to be 1 over 3x times, what's the derivative of 3x? Just 3. So what will happen is these 3's will cancel out and leave you with the final answer of 1 over x. A little different, right? Now, can we try to come up with the rule for this? I think we can. If you have y equals natural log of, like, I'm just going to make up another one, 5x. What's going to happen? What's going to happen? Let me do just one more, okay? You're going to have to write down 1 over 5x first. But you need to multiply this by the derivative of the log argument, okay? What's the derivative of 5x? 5. So if you multiply 1/5 x times 5, you will get 1 over x again. Okay? So I think we see the pattern. I mean, if you have y equals natural log of, I'm just going to make up a random one, 7x. Guess what? The derivative will be 1 over 7x times 7, which is 1 over x again. So anytime it is natural log of constant times x, it comes out as 1 over x. So these two are a little bit different, like depending on where that 3 is, we got different answers, but it's really just using chain rule for this second problem, okay?